economists and scientists of CH2M Hill, working for a better environment in the Pacific Northwest and Western Canada.
Tonight on Nova.
But I don't look at it. My interest in science is to simply find out about the world.
Richard Feynman. He built the atomic bomb, won the Nobel Prize for Physics, and he played the bongos.
4% Challenger.
NASA asked him to investigate the Challenger explosion and was surprised by what he found. Was this man the best mind since Einstein?
And by annual financial support from viewers like you.
I had a conversation about flying saucers some years ago with laymen. Because I'm scientific, I know all about flying saucers. So I said, I don't think there are flying saucers. So my antagonist said, is it impossible that there are flying saucers? Can you prove that it's impossible? I said, no, I can't prove it's impossible. It's just very unlikely. That, they say, you are very unscientific. If you can't prove it impossible, then how can you say it's likely, that it's unlikely? Well, that's the way, that is scientific. It is scientific only to say what's more likely and less likely, and not to be proving all the time possible and impossible. To define what I mean, I finally said to him, listen, I mean that from my knowledge of the world that I see around me, I think that it is much more likely that the reports of flying saucers are the result of the known irrational characteristics of terrestrial intelligence rather than the unknown rational efforts of extraterrestrial intelligence.
Theoretical physicist Richard Feynman was born in New York City in 1918 and died of cancer in Los Angeles in 1988. During an extraordinary life, his highly original approach to physics won him a Nobel Prize. He was a legendary teacher, spending 30 years at Caltech, and he was anything but the stereotypical scientist, leading a life full of escapades and wild adventures.
Feynman was a magician. With an ordinary genius, well, he does very good work, and it's not easy to do this kind of work, but you can imagine that if you try very hard, you could do similar work and get to a similar answer. But with a magician, you just don't know how he does it.
For a very long time, I thought everybody in physics understood physics like he did, except me. But he sort of internalized it. It was just as I know there's a chair here. He knew the laws of physics and how things worked, sort of totally internally.
Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we no, don't laugh, that's really true. Then we compute the consequences of the guess to see if this is right, if this law that we guessed is right, we see what it would imply. And then we compare those computation results to nature, or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. And that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.
A lot of times he'd get crazy theories about how physical things worked. But he was always putting his theories to the test. And that was a great thing about Richard, is whenever you ask a question and couldn't think of the answer, he'd always say, well, what experiment can we do to figure it out? And I remember once, for instance, we were making spaghetti, and that was sort of our favorite thing to eat together. We both enjoyed it, nobody else seems to like it. But if you take a spaghetti stick and you break it, it turns out that instead of breaking in half, it'll break in 3 pieces. So I said, Richard, Why is this true? Why does it break in 3 pieces? So we ended up spending the next 2 hours coming up with all these crazy theories about why spaghetti breaks into 3 pieces. And in fact, we ended up doing all these experiments, like breaking it underwater because we thought it might dampen the sound, and we had some theory, or breaking it at all kinds of different distances, or putting it on a table and breaking it off the edge and things like that. And so we ended up at the end of a few hours with all this broken spaghetti all over the kitchen. And no real good theory of why spaghetti breaks in 3 pieces, but a lot of fun experiments.
People say to me, are you looking for the ultimate laws of physics? No, I'm not. I'm just looking to find out more about the world. And if it turns out there is a simple ultimate law that explains everything, so be it. That would be very nice to discover. If it turns out it's like an onion with millions of layers and we're just sick and tired of looking at the layers, then that's the way it is. But whatever way it comes out, its nature is there, and she's going to come out the way she is. And therefore, when we go to investigate it, we shouldn't pre-decide what it is we're trying to do, except to find out more about it. If you say, but your problem is, why do you find out more about it? If you thought that you were trying to find out more about it because you're going to get an answer to some deep philosophical question, you may be wrong. It may be that you can't get an answer to that particular question by finding out more about the character of nature. But I don't look at it. My interest in science is to simply find out about the world. And the more I find out, the better it is. I like to find out.
Melville Feynman, a struggling businessman, transferred his own dream of becoming a scientist to his son Richard.
He had taught me to notice things, and one day when I was playing with a little wagon for children to pull around, it had a ball in it. I remember this. It had a ball in it. And I pulled the wagon, and I noticed something about the way the ball moved. So I went to my father and I said, say, Pop, I noticed something. When I pull the wagon, the ball rolls to the back of the wagon. It rushes to the back of the wagon. And when I'm pulling along and I suddenly stop, the ball rolls to the front of the wagon. I said, why is that? And he said, that, he says, nobody knows. He said, the general principle is that things that are moving try to keep on moving, and things that are standing still tend to stand still unless you push on them hard. And he says, this tendency is called inertia, but nobody knows why it's true. Now, that's a deep understanding. He doesn't give me a name. He knew the difference between knowing the name of something and knowing something, which I learned very, very early. He went on to say, if you look close, you'll find the ball does not rush to the back of the wagon, but it's the back of the wagon that you're pulling against the ball, that the ball stands still, or as a matter of fact, from the friction, starts to move forward, really, and doesn't move back. So I ran back to the little wagon and set the ball up again and pulled the wagon from under it, and looking sideways and seeing indeed he was right, the ball never moved backwards in the wagon when I pulled the wagon forward. It moved backward relative to the wagon, but relative to the sidewalk, it was moved forward a little bit. It's just the wagon caught up with it. So that's the way I was educated by my father, with those kind of examples and discussions. With no pressure, just lovely, interesting discussions.
One night I was already asleep, and Richard got permission to wake me up, and I can still remember him at my bed saying, Joan, I want to show you something wonderful. And I got out of bed, and we walked down the street to a golf course, and walked out in the middle of the golf course, and he said, look up. And there in the sky was an aurora. And he told me that it was an aurora and that nobody knew how they were formed. And